Just checking right now. Save questions for later. Alrighty, so check-in, test review, saving questions for later. Here we go. If you need to move in the room, I know I use the skinny pen, so if you need to adjust, please do so to better see the board. So here we go, starting off with the top half. Remember, there's also always a video on Canvas. Moving down now, 12, 13, 14. There we go. Guys, for the calculations, if you see two answers in red, one in a box and one outside, both answers are acceptable and correct and would both be given full credit. So those are two different ways for 13 and 14 to write the correct answer with the correct number of significant figures. And either one is fully acceptable. All right, moving to the back. Starting with 15, 16, 17. Again, both answers acceptable on number 16. Also, as discussed later in class, for number 16, it says what pressure, but I would clarify in your test that I wanted that pressure in kilopascals. So if you had not gotten to your clicker, I will tell you the answer in atmospheres was 2.56 to number 16. 2.56 if you'd left it in atmospheres, but that would be made clear in your test that I wanted the answer in kilopascals. right, and then wrapping it up with 18 through 20. 18 through 20. Alrighty, so with that, let's save our questions, but let's take our binder quiz. So getting ready for the binder quiz. And we're back from binder quiz and reviewing our other quizzes. So let's talk about your test tomorrow. I'm going to go over to the side to write all this stuff out that I'm about to write. All right, your test tomorrow consists of 5 multiple choice questions and 9 math questions. When you look at the point breakdown though, the multiple choice are only 12.5 points, whereas the math 87.5 points. All right, so clearly the math is the largest focus, but there are some multiple choice questions that would come a lot from those first 11 questions. Right, that would be where some of those multiple choice questions are going to come from, just on the concepts. Okay, so for the math, let's talk about what could be in the math section. Guys, I could just have you do for a full question just a pressure conversion. You would not need to show 3 steps, you would just do the T-chart. Your final answer sig figs which match the sig figs of the given, and that would be it. You've been doing this in step 1 recently, but we did practice this on the front of 33. That would just be a pressure conversion alone. Okay, so that's the first place you could have math questions from. Then there is the combined gas law. Right? You can take the letters out, so it may not have all 6 letters of the combined gas law. We could also have the variations for Boyle's, Charles, and Gay-Lussac with only 4 of the 6 letters. You have the ideal gas law. Those could be level 1, 2, or 3 questions with moles, mass, or density. And then remember there's Dalton's law. Okay. So looking at those math questions that you could have, there is no equation for pressure conversions. Pressure conversions are just setting up the T-chart using the standard pressures. The combined gas law is on your formula sheet. The ideal gas law is on your formula sheet, but you will need to remember Dalton's law. It's not too crazy. It's just the total pressure is equal to the partial pressure of the dry gas minus the water vapor pressure. We did in another one of these that came back on your mixed review, number 40, and then obviously the back of 31 is where we did 3 more of those. So this would be a main thing to remember that you might want to write down on your answer sheet whenever you start that tomorrow. No, it's dry gas plus, sorry, you are right. Plus water vapor. Okay. All right, so again, pressure conversions don't have an equation to look up anyways. You have the combined, you have the ideal, you need the Dalton. You will be given your periodic table in formula sheet, you will also need a calculator. If we review your periodic table, you would need for any molar masses if you had a level 2 or 3 ideal gas law question. And then don't forget on the back other information that's included here that can be helpful. Remember, it reminds you how to convert Celsius to Kelvin. At this point, that should not be a difficult thing for you. You're pretty good at it, but just in case you want to double check, make sure you're using 273, not 237 or some weirdness like that. It's there. Then they've reminded you of all of your standard pressures. So for your pressure conversions, double check. You have that there to refer to make sure you're using the right pressures, as well as if a question says at STP. Okay. All right, so here's your combined gas law. It's not in the cross-multiplied form, so I do encourage you on your answer sheet to write it in the cross-multiplied form. Whenever you cross-multiply, remember you take the numerator of the first fraction, multiply it by the denominator of the second fraction, and then set that equal to doing the multiplication in the other direction, the numerator of the second fraction, P2V2, times the denominator of the first fraction. So I encourage you to write that on your answer sheet, and then remember you can take letters out to make the other laws. They have to be the same letter removed. All right, so here's your ideal gas law, and then they've given your two different values for R. The way that the test is set up, that the units for the answers will be on there so that you know if it asks for a pressure, that you're going to know that the pressure is supposed to be in kilopascals or atmospheres. Otherwise, you can pick whichever one you want to match up with the pressure that was given in the question. All right, and then we haven't done any math with it this unit. We did that back when we did mole conversions and stoichiometry, but just a reminder, gas laws is where we kind of define this idea. 1 mole of any gas at STP occupies a volume of 22.4 liters. All right, so that is on your formula sheet. Then wrapping up here, last thing we have is there will be an extra credit question. The extra credit question will be integrative between unit 11 and 12. All right. Will be integrated with units 11 and 12. Okay, so I think I've covered, oh no, I haven't finished yet. So that's kind of the nuts and bolts of the actual format of the test. Let's talk about the test day. You're going to get an answer sheet. Here's what your answer sheet looks like, front and back. You'll notice at the top there's the 1 through 5 for spots that you could write down your multiple choice answers for those first 5 questions, and then you have room for all of your calculations. So remember, you're going to work through all the math first. You're going to write your sig fig rounded answers with units in the rectangular longer box. But like the mole test to help me with grading, I also have multiple choice options with insurance answers. So if your numeric answer matches up with something on the multiple choice, then you can write that letter down. But do not put a letter down if you don't have an answer. Some people lost partial credit. If you put down, if this says here, letter C is 1.132, and I don't have 1.132 on my paper, and I write letter C, I'm not giving you any partial credit. You are not to be guessing a letter. That is just extra. Leave it blank. I can still give you partial credit. I just know that you didn't get one of the 4 answers on this paper. That doesn't mean you're getting 0 points. So do not guess letters. With that, let me see. What else was I going to say? So yeah, work through the whole test. Obviously, the 5 multiple choice on the front, you can answer those with the letters. But on the back, do all the math. Do the 9 calculations first. Then at the end, look for the letters. Why do I say that? Because I've had it happen before. Somebody gets stuck on number 8. They do number 8, and then they start to look at the letters, and they're like, none of my answers matches up with one of the answers for number 8. And then they proceed to spend 15 minutes trying to figure out what they messed up on number 8 until they can finally get a number that matches one of the letters on my test. All right, and now you've just taken 15 minutes on a question that was only supposed to take you less than 5, and you don't finish the rest of the test. So that's why I encourage you. You're better off having everything worked through and not always have the correct answer. Use the time at the end if you can't find a letter that matches up to then try to see where you might have had an issue. Okay? Question, you had your hand up?
I forgot.
I'm sorry. All right, so that's the deal with the answer sheet and the questions. All right, so with that, any logistical questions about the test tomorrow? Yes.
So if we get an answer that's not one of those four, do you want to just like leave it?
Just leave it blank.
And then when we submit it, is it gonna like tell us our score?
No, because I still have to grade it. All right, it won't give you your score at all when you submit it, and if you leave something blank, that just tells me I need to go look and figure out your partial points. All right, are there any content questions then? Any questions we had from the test review after going over the answers? Go.
Can we go over number 18?
Number 18. Okay, so level 3 question. Right? I know it's a level 3 because I see density. So, kind of walking through that, how do we get to density? We start off with the ideal gas law. And the first thing we need to do is we need to do the substitution to get rid of N. So when we make that substitution, we get PV equals little mRT over big M. So far, so good?
Yeah.
All right, so then the next thing we need to do is move some letters around so that we can make what the density equation is, mass over volume. So when I do that, I divide by volume here, and that means I can also divide and just put it on the bottom of the already fraction bar that's there, put the V down there. So that these cancel, and now I can take out M over V and replace it with capital D. So DRT over big M. And so those are the letters that I need, and then, oh look, the question wanted pressure, so I get to stop there. That is my substitution and my final equation. Question?
I'm just confused on how, like, the little m and the v cancel out.
They don't cancel. We're doing a substitution. The density equation, density is equal to mass divided by volume. So this box, that number, those numbers, right, when I do that math, is equal to this. So I could have either one of those in my equation because they represent the same number. Right? It's a substitution is what we're doing. We're not canceling anything there. So the things I circle, we're substituting. If I cancel, I'm crossing it out. All right, so then that helps me with my list because I know that I'm looking for my pressure. Just put that in there, colors. Pressure equals. It gave me my density, 3.17 gram per liter. It gave me my temperature, 79 degrees Celsius, which I added 273 to get Kelvin. And then looking back here, the only other letters that I'm missing are R and M, right? The big M. What is big M again?
Molar mass.
Molar mass. So the R here, if I'm going to pick an R, this is going to be one of those cases, guys. I can just tell you when you have to get pressure, I'm going to default to kilopascals. Like I'm going to be using the 8.314 because as I told you previously, when we had done this unit in the past decade, they only gave you the 8.314. So that's why I will tend to default to that one. But then the molar mass. This is where some people got messed up there. Chlorine. Chlorine's one of your diatomic molecules. It's Cl2. So it's not just 35.45. It's 70.90 gram per mole. So Parker, do you want me to finish with step 3 or does that help?
No, my
Yeah,
problem was
so
in
once-
the algebra.
Yeah. All right. With that, I have seen some students who are mixing things up. Lowercase n. Lowercase n stands for moles, and the unit that would be after a number would be MOL. Lowercase m stands for mass. And what would the unit be for mass?
Grams.
Just grams. I see some students that are taking questions that have like 45.6 grams, and then they're changing this. They're making that gram per mole. As you cannot change a number or unit that was in the question. That is just grams. This, little m, mass. All right, so then what will never be in the question, but you may have to use, is the capital M, which we just said was molar mass. And what is the unit for molar mass?
Grams.
Gram per mole. And since that's a fraction, I always put that in its own column in my T-chart because the mole always goes on the other side of wherever the big M was. If the big M was on top, gram goes on top, mole goes on bottom. If big M was on bottom, gram on bottom, mole on top. Right? So make sure we're keeping those 3 straight, and you can't just change a unit that was typed on the question to something else.
And
Alright.
what was the molar mass of number 20?
Number 20, it would be the molar mass of krypton, which is what, 83.8?
Okay.
Yeah. Because krypton is not diatomic. Krypton, just
Okay,
one
because
atom.
Nitrogen gas was.
Yeah, but nitrogen is N2, it's diatomic. So if you want to review our diatomic molecules, guys, remember it makes the 7 in the corner of the table, NOFClBri, and hydrogen. Those are your diatomic molecules. Brinkelhoff. All right, other questions? Go.
And we're gonna get the back page of the.
Yes, you're getting the full one, the normal one that I give out on every test, so if you never knew, it is on the back. Yeah, you're getting this one. Yes. Number 3. Is that the real gas one?
Yeah.
All right. So guys, real gas, ideal gas. I know I mentioned stuff about pressure and empty space because I'm trying to prep the AP students, but really at this level, I'm focusing on the attractions. Which one has attractions? Real gases or ideal gases? Real gases have attractions, ideal gases don't. And so, because real gases have ideal attractions, what does that do to their volume? If they're attracting each other, would the volume be larger or smaller than what we would expect if they had no attractions? It's going to be smaller, guys. They're attracting. They're getting closer together. So that's really the take-home point here is that real gases, they have attractions. It pulls them closer, and it reduces their volume. It means their volumes are lower than what we expect for an ideal gas, right? Because ideal gases should have no attraction, so they should be further away from each other. Yeah? So that's the take-home point there with the real gases. Real gases have attractions, which means their volumes are lower than expected.
For number 16, why did you put 2 sig figs?
Number 16, 2 sig figs would come from, I didn't put 2 sig figs. That answer, wasn't it 260 point? That's 3 sig figs. Or 2.60 times 10 to the 2, that's 3 sig figs. When I put this decimal here, guys, what this does is it makes that 0 a sig fig. Now, if I put 0.0, that's too many sig figs. That's 4 sig figs, but I can just put the decimal, and then that means I get to start at the 2 and count everything to the right. But if I take that decimal away, I start at the 2 and I stop at the 6. So that's the trick whenever you want all of the zeros at the end to be a sig fig, you just put a decimal. Or if you wanted to put it into scientific notation, you could. That's why both of them are correct. All right. Other questions? So good. All right. So just last recap thing, when you guys get your answer sheet, which you can write on the answer sheet, 3 things I would encourage you to maybe write at the top of your answer sheet. The first one, Kelvin. Don't forget, all temperatures for all equations must be in Kelvin. I don't think anybody, maybe one person did mess that up. Okay. All right, next thing I would do, remember the combined gas law that's in fraction form. At the top of my answer sheet, I would probably write it cross-multiplied. So I would write P1 V1 T2 equals P2 V2 T1. And that way it's there for me to see on any questions that I need it, and I can just take the letters out and make sure I don't mess up and use a wrong version of that. And then since I know I'm going to have to use it, maybe go ahead and write down the Dalton one as soon as I get my answer sheet. Total pressure is equal to partial pressure of the dry gas plus water vapor pressure. So these 3 things might be helpful to write down somewhere, top or bottom. I know some students like to write down STP. That's totally fine, but just remember it's also on your standard pressures, at least, are on the back of the periodic table. So what's standard temperature, though? They don't actually officially tell you that. 273 Kelvin. All right, is there a hand? Is that you? Go.
Where do we have an example of like the Dalton law?
So if you want to see Dalton, go to number 40 question. What question was that? It was question 8. Number 40, question 8, or the back of number 33. In the back of number 33, that was questions 9, 10, and 11. Questions 9 through 11. So those are the places for the Dalton.
Okay.
Yep. So question 8 on number 40 or question 9, 10, 11 on the back of 33. Go.
When it comes to 8 on number 40,
Okay.
I think like for the Dalton's law, you don't really need to write in your list like volume and temperature.
You
right?
do not have to write volume and temperature. That's one of those things that if you recognize that this is the Dalton law question, I'm just writing it shorter. These are the 3 things that ultimately need to be in your list. Anything extra, I wouldn't penalize, but you got to at least minimum have the 3 things that are in the equation. Okay? All right. Other questions? Good. Okay, this is the last test of the quarter. After this test gets graded, I also put in some of your lab grades. So we'll be rounding out. This will be the last binder quiz, last test, and then lab grades. That should be the last stuff going in. Also, I'll do my dropping of an assignment, right? I usually drop 1 assignment grade at the end of the quarter as well. So wrapping out the 3rd quarter. Hey, ice cream supplies, make sure you're bringing those in. If you haven't forgot, I got the bucket over there. If anybody has anything today, just go drop it in your 2 bucket. Don't give it to another class. Keep it here. And if you are going to, for some reason, have a hard time bringing your stuff, especially if you're the only one and it's food stuff, maybe check with somebody. Make sure they can help you out. I can probably swing some extra bowls or spoons, but I'm not going to be able to swing extra milk.